a paper that was recently published about frog calls. And I worked on frogs, as you are well aware. And it is true that in the northern hemisphere, the spring equinox is a moment around which many people are beginning to hear a lot of frog calls. So there are more than 7,000 species of frogs worldwide, and there are a lot of ways that frogs hook up. A lot of ways for frogs to meet their mating partners. Actually,
And they do hook up
they
because
do hook
it's a
up.
very rare
Actually,
frog that has an extended relationship.
And here, Zach, you can just show my screen for a moment. I went back into one of the lectures I've given on amphibians over the year. This is various frog reproductive positions. It's called amplexus, and it's the male in gray and the female in white. And they just they don't have what's called an intermittent organ. They don't have a penis or equivalent, and so they just have to touch cloacas, and they figure out a lot of ways to do it. So that's kind of a hookup. And sometimes he does hook his fingers or his toes around the female, and sometimes amplexus can last for months.
Now, wait a second. Did you just say that no frogs have a penis?
Yes. However,
you see where I'm going with this.
I do. You want to go for it?
Well, I was just going to say, isn't there at least one clade, maybe it's even just one species that I think we have locally here? Am I wrong?
Yep. So it's the most basal clade of extant frogs, Ascaphidae, with the type genus
basal
Ascaphus. The common name is tailed frogs, and they are, yes, here in the Pacific Northwest and endemic to the Pacific Northwest. And they're called the tailed frogs. It's a tail. It's the remnant of a tail.
It is the remnant of a tail that functions as an intermittent organ.
I didn't look. I don't remember for sure, but I think so. Yes.
Okay.
But I'm here talking about frogs as if I know everything about frogs. Remember, there's over 7,000 species. I don't know all of them. I think Ascaphus truei may still be the only species. There may be more now. I think it may be used as an intermittent organ, but it's not a very good one.
Okay.
How about that?
So we are now engaged in escaphism, I would say.
Absolutely.
But it is interesting that it is basal. Because this is a little bit like the familiar example that people will know is the egg-laying mammals. The monotremes are basal to the mammal tree. So the point is
platypus and the echidnas.
So people will be familiar with a characteristic that was part of the early radiation of some clade that persists but was lost quickly, and therefore you only have the few species left, or in this case Ascaphus, maybe it's one species. But anyway, yes, so the exception that I wouldn't say proves the rule in this case, but it helps to demonstrate it.
Right. So lots and lots of ways for frogs to get it on, and lots, and actually the frogs that I've worked on sometimes give tremendous parental care to their kids. They have relationships with their offspring, but almost no temperate species do. Temperate species referring to the temperate zones where most viewers probably are, as opposed to the tropics or the polar regions, the Arctic and Antarctic. And to the degree that people are in the northern temperate zone right now, and it's spring now as of today, and they're hearing these choruses of frogs from local ponds, those are what are called explosive breeding assemblages. And
don't worry, it's not dangerous.
I have yet to find an actual frog exploding, although it could be interesting. I'd feel sorry for the frog, but that's not actually what it refers to. It's that these frogs who have been, depending on where they are and what species, hiding out, sometimes buried underground, literally frozen solid for the winter in order to survive the winter, like lots of crazy adaptations that frogs use to get through a harsh northern temperate winter. They are now convening in one place that is a good site for them to breed in, and these sites tend to be reproductively limiting for them, and so you get lots of species in one place, and they show up in these explosively breeding assemblages. Explosive, I think, really just referring to the fact that, last week there was no one there, and suddenly, my God, it's so loud I can barely hear myself think.
It's an explosion of frogs.
Yeah.
So, question for you. I can think of two reasons that you might have repeated evolutions of explosive breeding in frogs, and I'm wondering, maybe there's an explanation I haven't thought of, but do we know why this evolves repeatedly? So I would. So my explanations would be that one, it could be the ephemeral nature of the opportunity. That's probably so. To the extent that a pond shows up and is available for a brief time, there might be an optimal moment to breed in it, and all of the frogs would have some detector that would tell them when that optimal moment is. I'm doubtful of this because not all of the ponds will be ephemeral.
Not all of the ponds are ephemeral. However, the more in the temperate zone you are, the more important the seasonal change will be to getting it right in terms of like, this is the moment when you're laying eggs, because this is the amount of time your eggs are going to take to mature into tadpoles, and that your tadpoles will take to metamorphose into frogs. And those frogs have to be of a certain size and gained a certain number of resources before the next winter comes, or else they're more likely to die.
Okay, and watch this. If the pond isn't ephemeral, it is much more likely to have fish in it. And if it has fish in it, it's not so great for frogs. There are frogs that get along with fish to an extent, but when we typically find one of these ponds that has just, thousands of frogs in it, it tends to be fishless.
So it's I thought you were going to go to some degree concentrating all at once in a pond. If sites without fish are absent, then it could be a form of predator satiation.
That was going to be my other hypothesis, was that the explosive breeding, so the way predator satiation works, for those of you who haven't run into the concept, you have, let's say you've got frogs and they're predators. The population of predators is small when there are no frogs available, to the extent that those are specialists. And then if all the frogs breed at once, then the population of predators doesn't have an opportunity to rise. If all of the frogs bred in sequence, so they were available throughout the year, let's say that they were distributed across the year, then the egg predators would get more and more common, or even the frog predators would get more and more common, and they would rise to carrying capacity. Whereas if there aren't any frogs available or eggs available, then the population of the predators drops quite low. And then when there is suddenly a huge abundance of frogs, those small number of predators eat their fill and are done, and their population doesn't have a chance to rise to absorb all of the bounty that is available. So by concentrating it in time, they avoid a lot of the predation that they would otherwise face. Yep. I'm guessing that must be the primary explanation for explosive breeding in frogs.
It's I would say that goes in concert with, and it will be hard to separate from, the fact that in much of the southern temperate zone too, there's just less of it. The northern temperate zone, the winters are very hard on amphibians in particular, and all herps, all reptiles and amphibians, in part because they're not endothermic, and so they have to be collecting their heat from external, from the environment, and it's hard to do when it's -20 out, right? And so they have a relatively short period every year when they can actually, profit evolutionarily, when they can make a living for themselves and breed and all of this. And so there are, depending on species, either photoperiod cues or temperature cues. There are cues that prompt them to emerge, to, return if they were migrating, whatever it is, to show up, and that because it is a short period of time, having a fair level of precision on when the breeding season is also important. So I think those two things go hand in hand, obviously.
Cool. Well, that makes sense. And so, yes, we actually hear frogs. It sounds like they're ringing in our backyard.
Yeah, I haven't looked at, we just started to hear them, and I haven't actually looked up what they are yet, although it should be obvious. There's just not that many species of frogs here. And we don't have a pond, so I'm not sure. We have some creeks running through below our property.
Nearby, yeah.
Okay, so there is an Atlantic article out this month called this. Zach, if you would show my screen. How female frogs tune out useless, noisy males.
Ouch.
Yeah. So I at the end of this little discussion, I will say what I think about that headline. But the research it's based on is actually quite interesting. And here it is, just for a minute. It's published in Current Biology. It's called Lung-Mediated Auditory Contrast Enhancement Improves the Signal-to-Noise Ratio for Communication in Frogs. And I'm not going to walk us through the graphical abstract, but I kind of love that increasingly this is a thing now, that there are graphical abstracts that accompany research papers. Okay, so this paper, which came out, I think the paper was this month as well, basically says that it walks through some of the background that we just walked through. That specifically, and they're in the upper Midwest of the U.S. I don't remember Michigan, Wisconsin, Illinois, something. These explosive breeding assemblages often have several species in them, in part because these ponds are limiting, and frogs being frogs, and don't get me started, I'm not going to spend hours talking about all the reasons that frogs display the way they do, but it's basically they use sound. Frogs use vocalizations to attract mates. It's the rare frog that uses other indicators, although I have worked on some of them. And basically, you have distinctions between species based on frequency, both meanings of the word frequency, actually, like the hertz that the call is at, and also the the number of calls per unit time. So, maybe six rings per second as opposed to 2 is one version of frequency, as opposed to, I don't even remember what relative hertz frequencies would be, so I'm not going to give examples. I'll just be way off. And it turns out this research basically went looking at particular species, Hyla cinerea, that's American green tree frogs is the common name, are effective at dampening environmental noise in a particular frequency so that the individuals, and they only looked at females because it's mostly the females who are listening to, who are making choices based on the calls of the males. But presumably the males are doing this too. Females can better hear the calls of their own species. And so it's called the, where is it? The cocktail party effect, although I didn't write that down.
Just going to invoke this.
It's the cocktail party effect that, like, how do you might lean into someone, not that anyone's been in a cocktail party recently, but like that in a noisy environment, if you know that you're trying to hear someone, wouldn't it be useful to be able to tune out all the noise, right? And when you are in a breeding situation with a whole bunch of different species, and this part of the sexual selection on the species has precisely been to get the calls into a particular frequency range, in both senses of the word frequency, then you may be able to basically filter out the noise of the other species. And so, as much as I hate that headline that The Atlantic wrote, in this case, the males that the females are able to filter out, and I haven't yet told you how, but these researchers did actually find that the females are able to filter out the males of other species, and they are noisy and they are useless to them, right? It's not males of their own species that they're filtering out.
It's not a subjective judgment that they are useless. They are
right.
Gametically incompatible.
Gametically incompatible. And, the authors of this research paper did not use the word useless. That was an editorial snark from The Atlantic, not anything about the original research, which is quite good.
It was croakbait.
Oh, yes.
Yes.
Yeah, it was croakbait. Okay, good. So from the results of this paper, there are also a lot of unique things about frogs, including they actually have an additional tympanum, effectively, so they can hear at a greater range of frequencies than other tetrapods, which is, say, all the other vertebrates that came onto land, like us, or like our ancestors did. And they also have connections between parts of their bodies that we don't have. And so their lungs are actually, yes, being used as gas exchange organs, but also, it turns out, as dampening filters. So here's just a quote from the results. Inflated lungs created a notch filter that reduced tympanic sensitivity in a select range of sound frequencies from 1400 to 2200 hertz between the spectral peaks of the call. So again, so they're basically, they've got these, well, the other thing that's interesting here, and I didn't have time to go back and really check this out, but originally, like, lungs is a modification of swim bladders. Like, our lungs, tetrapod lungs, originally existed in fishy fish as swim bladders to help modulate buoyancy in the water column. And only at the point we came onto land, and some of the early sarcopterygians, the lobefin fish, like lungfish, extant forms that we have now, like lungfish and coelacanths, started to modify that swim bladder, which was no longer needed for buoyancy in the water column because they weren't spending time in the water column anymore, as an organ for gas exchange. And so here we have...
Which explains why it is such a god-awful design. I mean, imagine...
So how is it a god-awful design?
Okay, you make an organism, right, that has incredibly...
An organism, an organ.
known organism that has incredibly high needs for gas exchange, right? You make an endotherm that's burning tons and tons of organic molecules to release energy for heat and movement and all of this. And so the throughput of gases is the requirements are very high. And then you do it in a blind sack in which everything that comes in has to go back out. And you couldn't possibly load the thing with enough musculature to be able to eject water if you were to fill those sacks with water. So you have to go your whole life and never fill those sacks with water because there's no undoing it, right? Even hanging them upside down doesn't really work.
Yeah. Well, so early tetrapods are not endotherms, of course, and amphibians actually have multiple organs of gas exchange. They breathe through their skin as well. They breathe. They're basically if you spend time just looking at frogs, you'll see that their throats are always kind of pulsing, and that's actually gas exchange. They're actually breathing by doing that. They're not pulling it in through their mouth. They're actually doing gas exchange through the skin under their throat. But both the separate evolutions of endothermy in tetrapods, birds and mammals, have figured out different ways to basically help out the lungs.
Yeah.
So birds have accessory lungs in various places, little places of gas exchange, and then we mammals have a diaphragm. Right, so we have this thing that was just a transverse septum separating our guts from our pleural and our pericardial cavities north. Posterior to that, and that transverse septum, anterior to that, sorry, yes, and that became muscularized, and now we call it the diaphragm, and it helps us pull breath, but it can't help us get water out of our lungs.
In order to make it efficient for, basically every breath you're going to, take in your lifetime, it can't be effective for the rare case in which your lungs have filled with liquid. But, it all makes sense. If you think about the fishy fish, as you put it, the fishy fish do gas exchange in a much more elegant way than we do, right? Where the oxygenated water passes through in one direction. There's no need to eject it from a sac, right?
Right.
It just passes through in one.
Well, exactly. The water passes through the places of the capillaries, which are the places of gas exchange, are in the gills, and the oxygen gets pulled out, and then the water then continues back.
So it's a natural flow rather than pulling in the stuff and pushing it back out, which then creates this problem where you have a tube in which basically there's an amount of exchange you're not doing. If you think about a snorkel that was 10 feet long, and the fact that your lungs, you wouldn't be able to get enough exchange at the tip because you'd just be constantly breathing back in the same depleted air. So it's a bad design that we're stuck with, because initially it was a cool hack to a creature that for which it was a sufficient addition.
Right.
But we're now stuck with the consequences.
And there are, one of the favorite lectures I used to give was on the origin of tetrapods, and just and I'd ask students in the beginning, after sort of walking through some of the fossil evidence, just be like, okay, now you're on land. Think about every system that needs to be fixed or re-upped or changed or modified in some way. And I'm not even going to say the answer here. Maybe I'll come back in another, or if we're going to do this, I'll pose that at the beginning of an episode and come back to it near the end so that people actually have some time to think about it. But it's not just breathing. It's by a lot, right? It's not just, oh my God, I was breathing water and now I have to breathe air. I have to do gas exchange in which the medium that I'm pulling the gas out of was liquid and now it's gas. There's a whole lot else going on that has to be solved as you move from your medium being aqueous as opposed to gaseous.
Well, I'm looking forward to us having that conversation at some point, in part because in the time since you most recently delivered that lecture, I'm sure tetrapods have come a long way. And
no doubt.
We will learn all of the developments that have occurred in that clade.
Well, we're a mobile group in part, so we managed to make progress.
Yes, or pretend that we make progress.
Yes, we move ourselves relative to landscapes at any rate.
Yeah.
Basically, the upshot for me of this piece of research, which I love that frogs are doing this. I think this is such a great kludge-ish, like a use of an organ they already have on board. They basically lack the head shape or the technology for noise-canceling headphones, so they've got noise-canceling lungs.
Yeah, I think they lack the stick-to-itiveness, but
for noise-canceling headphones.
Yes.
No, I don't think so. I think, you don't have noise-canceling lungs, do you? No, I don't think you do.
Well, actually, I was wondering about this. So let me understand the explanation.
Yeah.
They inflate their lungs, and I'm having the sense that what this does is it just kind of puts tension on everything. And if you imagine the tympanum suddenly has more tension on it, it's not going to transmit certain frequencies. Is that what's going on?
I would have to look. Oh, I can't find the paper now. I think it's a little bit more complicated than that, and it's a pretty in-depth. Wow, that's not at all what I'm looking for. Yeah, I'm not going to answer that question because it's just there's too much here that I might get wrong.
Too deeply buried.
Yeah.
So I just want to, before we leave this topic, I just want to point out the interesting.
Look at that.
Yeah, geez. The interesting analogous phenomena that we have that we can tell in ours is done at the computational level, right?
We can tell that what of ours is done at the computational level?
The analogous process. So if you imagine, a situation you and I have been in where we're in, let's say, a tropical forest, and there's a noise that one of us has detected somewhere in tropical forests are very noisy places. There's a lot of stuff going on. And the process of saying, okay, do you hear that? No. Well, it's kind of a high pitch, like, and you can get somebody to tune in to those frequencies. And what this implies is that your ear was picking those things up all along.
Yeah.
But that your mind was throwing out the data because, of course, if you were processing all of the stuff going on, you'd be overwhelmed by it. And so you throw out most of the data except for the things that are relevant to you. But somebody can call your attention to somebody and say, shift this thing from category irrelevant to category relevant.
Right.
And then suddenly your conscious mind hears it. So that's definitely done at the level of, I hesitate to say computer algorithms, but
mind games.
Mind phenomena. Let's say cognitive phenomena.
So I do have a correction, and again, I'm not going to get into all the particulars, and I did not have time to fully familiarize myself with this article. But if you can show my screen here for a second, Zach, here is figure 2 from this article, in which they're showing the amplitude that is detectable when the lungs are inflated, they're higher, versus deflated. So it's when it's the lungs, the frogs are deflating their lungs to get the to get the dampening of the noise. It's not when they're inflated, but rather when they're deflated that they get the effect.
Okay, the lungs are deflated, and that dampens the noise. So maybe it is the similar mechanism to what I was proposing, but the opposite direction, like loosening the tension on a drum.
Possibly.
Yeah. All right. But I mean, I guess it depends which frequency they're looking for. But
yeah. Okay. And just to a reminder of the Atlantic's headline before we move from this topic. The headline was "How Female Frogs Tune Out Useless, Noisy Males," and I would say, when I first saw that, before I'd read either the Atlantic article or this paper, I thought, what the hell are they doing? And I thought, okay, actually, the males that are being tuned out are noisy, yes, and useless to the females who are tuning them out because they're the wrong species. But I will say that the use of the word useless there is just unnecessary, fashionable at the moment snark against males, in this case, male frogs. And the more the Atlantic does this, the more likely they're going to become useless to a lot of us.
Wait, but in many frog species, the term toxic masculinity would apply by virtue of compounds in the skin that...
However,
yes.
In those species that I'm aware of, in which the frogs, in fact, do have alkaloids or other toxins in their skin, and that's a lot of them, there's no sexual dimorphism with regard to toxicity. So it's equal levels of toxic masculinity and toxic femininity, which are in fact identical, and therefore it's toxic frog affinity.
Well, right, but that doesn't mean that we can't hold the male frogs to a different standard just because they're not right.
Well, I'm sure the Atlantic would. Yes, I'm sure the Atlantic would.